Assalamualaikum and salam sejahtera. Today I will give lecture on Solid Mechanic 2 BMCS 311C column eccentric loading part 2. For example 1, an axial load P is applied to the 30 mm diameter steel rod AB as shown for P equal to 35 kilonewton and E equal to 1.5 millimeter. Determine the deflection at the midpoint C of the rod. The maximum stress in the rod. Use E equal to 200 gigapascal, 30 mm diameter. Then E is the eccentric distance from the center to the P load. The length is 1.2. The condition for load apply is free. Using Euler formula, P critical equal to pi power of 2 times E times I over L effective power of 2. Then the C is half of diameter. I equal to pi over 4 C power of 4. So substitute the radius to initial formula. Then the L effective for pin equal to 1.2. Substitute the data to Euler formula. This is the P critical 54.5 kilo. To determine the deflection at the midpoint, using this formula, E times bracket secant pi over 2 square root P over P critical bracket minus 1. This is the formula to determine the Y max at the midpoint. Substitute the data to Y max, so you will get 3.4 millimeter. The maximum moment equal to load times eccentric plus Y max, the deflection at the midpoint. So substitute the P or load plus bracket 1.5 for eccentric plus Y max 3.4, you will get moment 171.5 Newton meter. Calculate the area. Then to determine the stress max equal to P over A times MC divided by I. This is the load applied to the column divided by area. Then this is the moment value. The C is half of diameter divided by I, so you will get 114.2 megapascal. Example 2. The uniform column consists of 2.4 meter section of structure cubic having the cross section shown. So the effective is eccentric equal to 18 mm. The condition of the column is fixed and pin. Using Euler formula and factor of safety of 2, determine the available centric load for the column and the corresponding normal stress. Found in part A, apply at point 18 mm from the geometric axis. Determine the horizontal deflection at the midpoint of the column and the maximum normal stress in the column. This is the data given for this column. The effective length for this column, pin fixed, so the value K is 2. So this is the length of the column 2.4. Then you need to times 2. So the L effective equal to 4.8 meter. To determine the critical load for axial load applied at the center of the column using Euler formula equal to pi 2 times E times I divided by L effective power of 2. Substitute the data to the Euler formula. So we get to 85.3 kilonewton. So the available load P available equal to P critical divided by safety factor 285.3 divided by 2. So the P available equal to 142.7 kilonewton. To determine the stress, P available divided by area given in the question. So the stress equal to 62.5 megapascal. So the load applied with eccentric given by E equal to 18 mm. So the maximum deflection, deflection Y maximum equal to E eccentric bracket secant pi over 2 times square root P over P critical minus 1. Substitute all data to the Y max formula. You can determine the Y max equal to 22.5 mm. To determine the maximum normal stress, this is the formula to determine the normal stress. So using this formula, you can determine the stress maximum. Example 3, they have a load applied of magnitude 270 kilo parallel to geometric axis of column and B, and detect the axis at E equal to 14, eccentric equal to 14 mm. Using E equal to 200, determine the deflection at the midpoint of the column and the maximum stress in the column. So this is data given for the code of W200 times 52. So this is the list down. So the condition for this column is pin. To determine the P critical, this is the Euler formula. Substitute all data to Euler formula. You can determine the P critical 677.77 kilonewton. So this is the formula to determine the Y max. Okay, substitute all data to Y max formula. Then we get 11.57 mm. To determine the stress max, this is formula for stress max, P over A times mc divided by I, or P over A times moment over sy. Okay, substitute all data to the stress max formula. You can determine the stress max equal to 80 megapascal. Okay, example 4. Axial load applied at point D with eccentric 6 mm from the geometric axis of square element bar for BC. Okay, BC. Determine the load P for which the horizontal deflection of NC equal to 12. So this is a Y max, and the corresponding maximum stress in the column. Use E equal to 70 gigapascal. So this is the Euler formula to determine the P critical. The L effective for this column is a fixed free. So the L effective equal to 2 times of L. So 1.5. 1.5 substitute to the Euler, 1.5 power of 2. Okay, pi 270 times 10 power of 9 for Young modulus. Then we get P critical 95.9 kilonewton. This is a Y max formula. Substitute all data to the Y max formula. So in this question, you need to determine the P value. So the secant become cos. Then the P over P critical 2 over pi cos become up cos, because up cos is 1 over cos minus 1. So the P equal to 0.61411, P critical equal to 58.87. So the stress max equal to P over A times MC divided by I. This is the formula to determine the maximum moment equal to P times eccentric plus Y max. Y max is 12, the eccentric is 6. The P value they get from here. So the moment maximum is 1060 kilonewton per millimeter. Then substitute all data to stress max. The stress max equal to 105 megapascal. Okay, example 5. This hollow pipe with diameter 102. The eccentric value is given by 5 mm. So the length is 2.8. You need to determine the horizontal deflection at the midpoint is 5. So then the corresponding maximum stress in the column. So the condition for the column is pin. So the L effective equal to 1 times L. So the L effective is 2.8. Substitute the L effective to the Euler formula. 2.8 power of 2 by power of 2. This is the E value. Then this is the inertia formula for hollow pipe. So you need to memorize this formula for hollow pipe. So the P critical is 528.8 kilonewton. So to determine the P value, you need to use this formula, P over P critical 2 over pi up cos. Up cos pi over pi plus pi power of 2, you get 0.444. Then the P value is 235 kilonewton. Then to determine the stress max using this formula, substitute all data that you get from previous calculation. Then the stress maximum become 149.6 megapascal. So in this slide they have 3 exercise. So to make you familiar with eccentric load for this chapter, you need to do exercise and the example given. Thank you.